So just like things can grow exponentially, they can also decay exponentially. And that's when situations go down or decrease. Now, let's take a look at an example which is fairly common. If you're paying off some debt, some amount that you owe, which is common and a good idea. If you owe $1,350 and you're paying off 10% each month, let's see how our exponential growth formula also works for exponential decay. We're going to put our y equals, we're going to put b, our beginning amount, $1,350. Now before, when we found the g value, and it was a percent, we took 100% and we added that percent on. But if we're decaying, we're going down, so we're going to want to subtract, right? So if we take away 10%, how much debt are we left with? We're left with 90% of the debt that we had. And if you move that decimal 2 spaces, that gives us a 0.90. And then we've got the x for the exponent for the time periods. In this case, it'll be each month. So I've already done some calculations here. I put in 0, 1, 2, 3, and 4 months in for x. And here are the values: 1350, 1215, 1093, 984, 885. And what you should notice is that from here to here, the very first month, you paid off over $100, $135 in debt. But as the months go along, if you're still paying 10%, because there's less money to begin with, you haven't even paid a whole $100. So as you graph these, it starts and curves flatter and flatter as you go. A little bit different than exponential growth, but still very similar. Just remember to subtract instead of add.